Alright, so we do only have like 2 sections left, like we're gonna look at them, but one of them like tomorrow, I don't even know, maybe we won't do it tomorrow, we're gonna do like a little activity and kind of get into it more on that one. So the one thing we did do last year is mainly handle this. There's one big theorem in this section, which I don't know if we'll get to that today, but there's one big important theorem in this section, and it kind of comes up on some AP problems, and it's kind of the thing, one of those things they used to try to break the 5s from the 4s, so we're definitely going to look at that theorem. But this guy is mainly about continuity, which we talked about, so we talked about that, and one-sided limits, which we also talked about. So today should be familiar to you, should be review still. Remember, I said that there's a big distinction between a function being continuous somewhere and a function just having its limit exist somewhere. Those are different concepts. Yeah, they're kind of similar, but they're not the same concepts. You got to get that out of your head that they're the same. It's very easy to think they're the same. So what is the definition of continuity? Remember, there's the informal and the formal. You guys remember the informal. When's a function continuous?
When you
don't have to lift up your pencil.
When you don't have to lift up your pencil, right? So we know the informal definition, which is nice. I mean,
it's easy enough to remember.
it is. So that's. Do we talk about continuity everywhere at once, or where do we talk about it usually? At a specific spot, right? Like some specific point. Oh.
Do you want me to remove all of these self-registered
Yeah. Leave some of them. We could unregister all those people.
It's a bad grade. Nothing's not. Feeding the lemurs looks good. Feeding the lemurs looks good. But everything else is just compact.
Yeah, you could.
It's all my fault.
It's not all, oh my god, it's not. I just nothing with my way to like today, instead of being able to work on our paper, we had to watch that quickly. And then in chemistry, we have to retake the test instead of just getting half our points back.
Okay.
Thursday.
Yeah.
It's just 52 on it.
Me too.
Well, that's the
Sorry for the interruption. Okay, so the informal definition is a function. Let's just use a different letter. H is continuous. That's what we're defining. At a specific value, if you can trace it. Without lifting your pencil. I don't think that's quite enough, really. What else do I need to put on there? Since I'm looking at a specific value, do I need to be able to trace it everywhere for it to be continuous there? How should I say that then? Yeah.
And you don't have to lift your pencil at x equals c.
Yeah, I like that. So when you don't have to lift your pencil at x equals c, so or if you can trace it without lifting your pencil in the neighborhood. I love that word, neighborhood. Maybe I'm just a Mr. Rogers fan, you never know.
It is.
He died.
Sad.
I know. What did he do with
I love that word neighborhood though because it has
It's
just
called
such
Mr. Rogers'
awesome
Neighborhood.
implications later on.
You never watched that as a kid?
No.
It was the
Yeah,
best
like a little
show
train
ever.
and like the train would follow.
We
Troll
had
train.
cable
Okay.
when I was a kid.
Train.
So
The
we
guys are
watched
on
it.
camera, you know.
How? But the train would like go when I went to the
Okay, formal definition.
It's incredible.
It was incredible.
Now, let's just say this. So f is continuous at x equals c if the following conditions are met. Remember how many conditions there are?
3.
Yep. And this is the real meat and potatoes. So if it says decide if a function is continuous and show it, you better show all 3 conditions are satisfied, right? So the first condition, or any of those conditions, can you guys tell me what they are?
There's one like x equals, yeah.
Mr. Bodino said f of c exists. It is defined. He even used the word is defined.
when you say that, you're saying like if you put C into the equation, you
Right,
would get an
so that's
actual
pre-calc,
answer.
right? Yeah,
So that's easy.
yeah.
Okay.
The limit of f.
But sometimes that's not true, right? Like for an asymptote, that's not true. Do you ever have a hole without a point? Yeah. So that could not be true. What else?
It's like the limit of f of x as x approaches c exists, and then the other one is that they're
So the
equal,
limit
right?
is, so this says at C, you get something. This says as you approach C, you get something. Could I say it is defined there? Yeah, I could. Either way to say it. Same thing, right? Exist is defined, same
And they
thing.
have to be equal to each other, right? Or something.
Right.
Yeah.
So they have to be equal to each other.
So
So you can't just have the limit exist and a point exist. You've got to have them be equal to each other. So the limit has to equal the point.
Oh.
Okay, that's what continuity is. Notice, if you're tempted to just think, oh, limit, continuity, same thing.
But
The
not.
limit part is only one of the three parts, right? Still easy to
Don't
confuse
have
though.
to equal c to exist.
Okay, so the book is going to mention this just so you have some vocabulary. If you have a place where your function is discontinuous, or that it is not continuous, this is mainly just our textbook making this distinction. I like it though because a lot of upper level textbooks talk about this. So discontinuities can come in two different types. Remember that theorem we learned that let us essentially fix whole problems?
Zero either twice.
No, I don't remember that.
Either.
Well, we just learned it. It was one before the squeezy one.
You have either twice.
Yeah.
You have either twice. You have either twice.
Maybe either. I like either better than either.
Okay.
Oh, either.
So they can come in two different types. There's the ones that that theorem can fix.
Depends on what.
Those are called removable. And they look something like this. So you have some kind of function curve, f. And you're checking to see if it's continuous at C. But there turns out to be a hole there. And the point's somewhere else. Is the function continuous at C in that case?
No, because you have to lift your
No.
thing.
Which thing is not satisfied?
Well, 3. They don't.
Condition 3. That's true, but that's not true. That's what the problem is. In that case, though, you can call this a removable discontinuity. You can kind of fix it up and make something out of it.
Could you just move the dot down?
Sometimes they're not, though.
Move it down. Move it down.
I don't think that's the best solution.
What
also.
might a non-removable discontinuity look
Well,
like?
then you can't fix.
An asymptote, yeah, or a jump, yeah. So let's try a jump.
Fixable one.
That guy, there's just nothing you can do. So the book does categorize him like that. AP really doesn't
It's
care, but-
terminally ill.
Yeah, it's terminally ill. Okay. Let's talk about a one-sided limit. This is only one, still, this precise formal definition of continuity is still only one way to do it. There is another definition. We need something for that definition, though.
Oh, is that the definition from the other guy?
Yeah, so this is just an alternative definition, and yes, these are like the two different ones. They both are equally good. But let's just do an example. So let's say we had this problem. So example,
Just against the I feel like I can kill something right now, actually.
we're the two guys, though, Austin. You should know their names.
God, don't do this to me.
Can someone help him?
The one was a weird
His
name.
mind is too overloaded with
Is this
American
what we were
history.
talking about?
It's new. Was one of them
Newton?
Isaac Newton, and
Okay,
then
and
the other one had the
Lowe-
weird name that I don't
It starts with an
remember.
L, doesn't it?
Lars
Leibniz.
Leibniz.
It was like Godfrey.
Yes, Gottfried Leibniz. Very
Speaking
nice.
of, okay, we were just talking about Newton and the Enlightenment in U.S. history. Just saying.
That's good. Okay, so what's the only difference with this and the problem we've been doing?
It's one-sided.
So we know that this guy right here, this means it's a limit, but it's not both sides. It's one-sided coming from, that's coming this way. This is from the right. If you have a minus there, that means from the left, right? How would I deal with this limit?
Factor and cancel.
I'd factor the bottom and cancel, so what's it going to turn into?
X plus 5x minus 5.
Or
Right.
1 over x.
So, do it.
Wait,
Mama Jumbo, you get this. Correct?
I don't.
Because you factored it, so you have an x plus 5 and x minus 5.
How did you just get a 1 on the top? I don't-
Is there x minus 5?
You had to put something
Oh, okay, sorry.
Okay.
Yeah.
That's stupid.
I'm not going to show my head.
there.
No, I'm
Because
sorry.
that
I'm,
one-
I'm
That's
an
from Mumbo
idiot.
Jumbo.
You might want to.
It's crazy Mumbo Jumbo.
Okay, so what allowed me to go from this step to this step, remember? It was that theorem that said you can replace f with a function g as long as those guys are equal everywhere except at 5. So does this work also for one-sided limits? Yeah, it does. And you're going to get 1/10 now when you plug in, right? So notice, that didn't really affect it too much.
So that's the limit.
Right, so like, if you have a one-sided limit, it's not necessarily always going to change the way you approach the problem. Only sometimes. Remember that we had that great example. Do you guys remember that great example we had?
No.
Is
We
it
had
mostly
that-
affected like when you draw the graph? Or?
Yeah, but I mean,
You may need to get some help.
thinking about the graph. Yeah, like this. Remember that square root of x example?
Yeah,
What it
it's-
means.
Okay.
Oh, I already came across it, and I thought that'd be great for your leadership class.
Okay.
What is it?
Okay. I'll read it.
So the square root of x. If I take the limit as x approaches 2, is it going to matter whether I come from both sides or one side? Nope. How about 3? How about 4? Where are we going to have an issue?
0.
The limit from both sides, the limit as x approaches 0 of square root of x is what?
Does not exist.
It doesn't exist. It's not a defined limit exactly. But
If you're doing 0.
if I do this
Plus.
plus, what is it? 0 if I'm coming this way. If I do it from the left, of course, it doesn't exist, right? And you need it to exist from the left and the right and be the same thing for the overall limit
So
to
that
exist.
is not continuous at 0, right?
That's also true because it
Okay.
disobeys.
Well, the first, there's a limit, but
There's a point.
No, it's the last one.
Robot shut
There.
off.
There's
Oh
a
no,
point.
because you're not coming from both sides.
It disobeys condition 2, the limit doesn't exist. Okay.
But okay.
It would disobey condition 3 too because, well, the limit doesn't exist, so it can't equal 0, right?
But it does exist when you have a little plus.
Right, but I'm just saying sometimes, and Cassidy was right to point out, you'll usually have to think about it graphically for those things to come up. So if something happens when you're doing it algebraically and you're like, what's going on here? You might want to go consult the graph and see what's going on there, okay? All right, let's look at maybe one more, and maybe stop for today. So let me try to draw a picture.
So you kind of focus on math or I'm gonna fail. Sometimes I wish I was just a slacker. And I didn't do anything.
No, you don't.
No, because then I feel stupid. But if I was born that way, I wouldn't
you
feel
were a
stupid because
slacker,
that's
you
just
wouldn't
how I
know.
am.
Exactly.
Your life would be boring.
Miss me, slackers, I bet like if
Grow
I was
up being a
if I was
drain
a
on
slacker.
society.
But listen, what if I was a slacker? My parents were billionaires. Then I wouldn't be a drain because I already have the money.
You would still be a drain on society.
Yeah,
You'd
but
be
I
a
wouldn't
drain on
drain
your
more
parents.
money. I would just drain my
Maybe
parents.
more on your parents then.
Yeah.
Okay, that's right. Okay.
Don't talk about me behind my back.
What's that?
Kyle, I need help out. This is too hard to get back.
Okay, Kyle, you're gonna help me.
Okay. Sorry, I was talking, but
I think those should be not bad. Can you help me out?
Mr. McGee, is there any student you absolutely hate? And if it's me, don't answer.
2.
Would it the first one be 2?
Yes, sir.
Did you say that loud? I was trying to hear.
Because he told me to help him. And the O was 1.
The other one is 1. Thank you. So, if I go and ask you, does the limit as x approaches 2 exist?
No.
You say no. because you think either there's a jump there, or I know that coming from the left-hand limit and the right-hand limit have to be the same.
Yeah.
We also can say, what do you guys think about the continuity of
It's
G?
not continuous, it's zero.
And that's because the
Limit doesn't exist.
limit doesn't exist. It disobeys condition 2, right? Another way you could think about this is with an alternative definition of continuity. An alternative definition of continuity says, so let's put it somewhere, here. Continuity revisited.
You're just like the stats book.
Continuity, the final
Yeah.
cut.
That's what does say that.
Director's cut.
So you can say, let's use this guy, g of x is continuous at a place like x equals 2, which it's not in this case, but we could say it was continuous there if,
You can say it's very close together, and I always thought you were like,
If x approaching 2
I love making my own
plus and
vocabulary
x
terms.
approaching 2 negative are the same.
Are you making some new
That's
speak?
like redneck.
Yeah.
redneck.
Fuck, it's like,
So, do you know what I'm doing? Typically, I just want to throw it into the big glass house the way or watch the
somebody help me out?
The limit of x approaching 2 plus and the limit of x approaching 2 minus are equal.
Yes, x approaching 2 of what?
F of x and g of x.
So, if you were asked on the AP exam to demonstrate that something was continuous, then you could very easily be asked that. There's 2 ways to do it. You pick what you like.
So
last year people really
whose-
liked this.
whose-
That's a really
whose-
easy way
whose
to
is
show
that?
I don't remember who's these
Oh.
are. I don't remember which one's which. Sorry, Austin. Good question. So you can either show that the right-hand limit is equal to the left-hand limit, and that's it. Like that shows that it's continuous at that point.
That's a really quick way to do it.
But the question is, sometimes demonstrating this might be difficult, like we said.
If you
What
have
if
a
you're
really
not
hard
allowed to use the graph there?
Yeah, that's
Or what if like doing this algebraically is difficult, whereas doing the regular limit is a little bit easier? Or what if you're just getting confused about the right-hand side, so maybe it's better to do it the other way? I don't think one is preferable over the other. Last year people seemed to like this one better. I've always liked the other one better. Either way works. Okay? We're going to talk about the intermediate value theorem, but I'm going to leave that till tomorrow. I don't think we're fresh enough today. Okay?
Yeah, those potatoes.
It's hard when it's the like second to last class of the day.
Probably have 2 more classes that are